In this video, we're going to talk about the Kirchoff's laws. Now, under the Kirchoff's laws, we got two laws. That is KVL and KCL. So we're going to start with KVL. Now, KVL, that stands for Kirchoff's voltage law. Now, the Kirchoff's voltage law states that the sum of the voltages or the potential differences within a closed loop will be equal to 0. So let us say we got a closed loop like this. So this is the EMF source or the battery. And let us say this is the first resistor. This is the second. This is the third. Now you need to understand that as far as you got the positive terminal for the battery situated there and the negative terminal going that way, now we're obviously going to have current rise and go in this direction. And so if you got this, that means you're going to have some current pass through I1 or R1 rather. Now you need to know that from the Ohm's law, V, that is equal to IR. The current multiplied by the resistor, that will give you the potential difference or the voltage. So if we have this current multiplied by the first resistor, we're going to have a voltage displaced upon this resistor. Let us call that voltage V1. So that will be I multiplied by R1. Now we know that these three resistors, they're actually connected in series. So we're going to have pretty much the same current go through the second resistor. And so if you have I go through R2, there is going to be another voltage dissipated over the second resistor. So let us call that voltage V2. So V2 will be equal to I multiplied by R2. Next up, we're going to have a voltage dissipated over the third resistor. Let's call that voltage V3. That is as a result of the product between the current sent into that resistor multiplied by the resistance that was present there. So as you can see, we got three different voltages that will be applied on various loads or resistances connected within a circuit. Now you need to understand that this battery, that is actually the voltage source. That is where all the voltage would be deducted. So you need to understand that E is a battery source, and that will be equal to V1 plus V2 plus V3. That's basically how it works. Now, if I wanted to take three voltages to the left-hand side, this is what we're going to have. I'm going to have E minus V1. This is going to be minus V2 minus V3. So this will be equal to 0. Now, we got negative sums. Subtraction could also be called as negative sums. So right here, you can see that we got the summation of 4 voltages or potentials, and that equals to 0. So this basically explains how the Kirchoff's voltage law works. This is one loop, and it is closed because, as you can see, there is no openness within the sub-circuit. You could also have more than one loop. Now you could also have something like this. Now if you got something like this, we got two boxes present here. So if we say this is the EMF source or the battery, and let's say this is the first resistor, R1, this is the second resistor, R2, and here we're going to have the third resistor, R3. As you can see, there is two boxes which would actually be called as loops. So the first loop here, 1, and the second is this one. So here we got two loops. Now if we add up all the potentials within the first loop, that must equal 0. And the same case goes to the second loop. So if we add up the two potentials present within that, that would result in 0. So basically, that is a statement for the Kirchoff's voltage law. Now, obviously, we're going to solve questions involving this, but we just need to introduce the idea for the Kirchoff's voltage law. The sum of the voltages or the potential differences in closed loops would always be equal to 0. Next up, we're going to talk about the Kirchoff's current law. Now, the Kirchoff's current law states that the sum of the currents that enter into a junction, that will be equal to the sum of the currents that leave the junction. So let us say we got a resistor and we got two other ones. So let's say this is the first resistor, R1, and this is the second. Let's say this is the third. So let us say we had current coming in this direction. So let's say this is current. Now, as the current comes to this junction, there's going to be a split. That is the junction. So the current that comes into that point, let us say that is I1. So as I1 approaches this point, there's going to be a split. And I1 is going to split up to, let us say, I2 and I3. So we're going to have something like this. Well, that should be I3. And I'm going to label this one as I2, like that. So what we want to look at is the fact that if you take the sum of the currents that enter into this junction, that will be equal to the sum of the currents that leave the junction. Okay? So in that case, we're going to say that I1, which is the sum of the currents that come to this junction, that will be equal to I2 plus I3. This is what you get. Now, you could also have pretty much many other examples. Let's say, for instance, you had something like this. Well, I need to redraw that. So let us say you had stuff like this. And so we had 3 resistors. This is R1. Let us say this is R2. This is going to be R3. Let's say we had current move in this direction. Let's say that is I sub t. That is the total current that enters this junction. So as the current comes to the junction, there is obviously going to be a split. And so one current goes to the first resistor. You could feel free to label that as I1. And the next current goes through the second resistor, which is going to be I2. And the third one goes to the next one, which is I3. So this is I1, this is I2, and this is I3. Therefore, we're going to say that IT, that is equal to I1 plus I2 plus I3. Now, as we come to this other part of the junction, this point, you're going to see that we need to add up the 3 currents to form the total current that enter the junction from this other side. So in that case, you can see that the sum of the currents that enter into a junction, that must be equal to the sum of the currents that leave that junction. You need to hold these at the back because it's really going to be helpful as we try to solve questions. Now, there's something else I need to show you. Now, if you got a battery and that is represented in this way, what is going to be the direction of the current? If you got a battery oriented in this direction, what is going to be the direction of the current? How are you going to show it? So the first thing you need to know is that the longest stroke, that stands for the positive terminal. So this is going to be the positive. This is going to be the negative. So in that case, you already know what to do. Current is always going to emanate from the positive terminal and lead on to the negative. So there is always going to be this direction for the emanation of the current. So current goes in this direction. Now, what if we had it this other way? So we first need to represent the positive terminal and the negative. From there, we can pretty much tell where uh, the current leads. So it's going to be in this direction. That is because the positive terminal leads this way. Okay, so the current obviously is going to move that way. Now that might not be completely the case for every battery or loop as you try to move. Although we know that the current is going to be delivered in the direction where it's chosen. But as we solve questions, you're going to see that sometimes you're not really going to use this to decipher whether or not current will come out from that point. So just bear these at the back. This, for the beginning part, would actually be useful. So let us just hold it. Now, what if we had a resistor and you got current that moves in this direction? What is going to be the symbol for the terminals on this resistor? Are you going to have a voltage drop or a voltage rise? How can you show it? Now, if you got current moving from one part to another part, that always happens wherever you got the potential being at a higher point than another point. So if you have a potential at one point greater than the potential at another point, then there's going to be current emanating from the highest point to the lowest point. And that creates the potential difference. So I'm just going to say that if we had a point A, okay, so you got a point A, and then you had another point B. If there was a resistor at this point, we know that the potential at this point, that is going to be called VA. The potential at this point, that will be called VB. Now, as we move from this point to this point, that would only happen if we had VA being greater than VB. So let us say this was greater than this. Therefore, current is going to move in this direction. Now, if current moves in that direction, that means VA minus VB. That is going to give you the voltage that will be dissipated over the resistor. Let us say that voltage is written as V sub R. This stuff is going to be called the potential difference. Why do we call it that way? That is because this is a potential. This is also a potential. So if you got one potential subtracted from the other, that's obviously going to be potential difference. And that potential difference was dissipated over the resistor represented in green. So basically that is how it works. Now you're going to need it as you come to solve various questions using various techniques in Kirchoff's laws. Well, not really Kirchoff's laws, but DC circuits or circuit analysis as far as we talk about DC circuit direct currents. So coming back to this point, we know that if you have current moving from one point to the other, that means this got a higher potential as compared to this. So therefore, there is going to be a positive charge. This is going to be positively charged, and this will be negatively charged. Here, we're going to have a higher potential. That is going to cause current to move in that direction. So by the time we come to this other side, there's going to be negative. So that's basically how it works. Now, if we got current moving in the other direction, like this, that means we're going to have a negative here, and there is going to be a positive on this other side. You need to know this because we're actually going to use it to solve questions as we move on. So really bear that at the back. Now, how about this one? Let us say that we got a resistor and you wanted to analyze the circuit analysis for various resistors, and you were moving in this direction. In such a case that we got a positive terminal for the resistor here, and on this side we had a negative. Would you have a voltage drop or a voltage rise? How are you going to show it? Now, if we come through this direction, what that means is we end on a negative note. So that is going to be a voltage drop. Okay? There is going to be a voltage drop because we ended on a negative note. Now, you could also have it in the other way. Let us say you have something like this and you moved in this direction. Now, if you had negative and a positive here, this is also going to be a voltage drop because the direction of the loop, that is in a negative direction. So there is obviously still going to be a voltage drop or potential drop. Now, you could also have another one. Let us say you got this, and let's say you had a negative and a positive, and you had something like this. This is the direction of the motion. If you had something like this, that means there will be a voltage rise. So there is going to be a voltage rise at this point. That is because we ended on a positive note. So there's going to be a voltage rise. So you really need to hold these at the back because this is actually going to be very useful as you come to solve various questions. Now there is something I want to show you finally. Let us say you had something like this. Let's say this is the first resistor. And so this is the second resistor. And we had this to be the third. Let us say we had first current come to this point. That is I1. We know this is a junction. Now, as the current approaches the junction, what is going to happen? We obviously know there should be a split in it. So let us say one current goes downwards. That current is going to be called I2. Well, we just designed the name for it. You could call it whichever name, but we just want to call it I2 for the sake of synchronicity. Now, there is also going to be another current that goes to this side. Now, we know that this is a total current. The total current split up into two. And one of it goes downwards and the other has headed to this direction. So we know that if you take I2 away from I1, you're going to find the amount of current that goes through I3, right? So we could say this is I3, or we could say this is I1 minus I2. Whichever way you want to call it, that is going to be correct. Now, we might not really want to use this one. That is because as you try to solve questions, you're going to have too many unknowns or variables. Now, you don't really want to have that. You want to have so few variables that you're going to be able to solve questions much more easily. If you got 3 variables, you might need to create 3 equations in order to solve it. But if you just got 2, you're just going to need 2 equations to solve it. And so you want to go to the point where you're going to have less number of unknowns. So if we use I1, I2, and I3, that is going to make us have 3 variables. Now we don't want that. So you should rather go for this. This is most recommended. I'm so sorry, the noise in the background. I'm really having cold on guitar. I just hope that doesn't affect anything. Now, how about this? Let us say this is R1 and this is R2. This R3 and this R4. And so this is R5. Now we know that some current might be shot or sent into this network. So if you gotta have a split up, this is gonna be a first split. This is the first junction. There's another junction. This is the second junction. So if you got these 2 junctions, do you just need to say that you got I2 going through this, and then this, we got I3? Would you want to say it that way? Or you just want to take it to a lower number of variables that will make you be able to solve the questions a lot more easier. So we would actually want to use that method. If we say this is I3, that is going to be much more hectic. But there is an easy way to do it. We know that I1 is the total current, or the current that was released into the circuit. So as it comes to this junction, well, I'm just going to name this junction A. Let this be junction B. As I1 comes to the junction A, there is obviously going to be a split. And the first current will be called I2. That is the current that goes to R2. And the next current that goes to R3, we know that will be the difference between I1 and I2. That means if I took I2 away from I1, I'm going to have the current that goes through I3. So that is basically going to be called I1 minus I2. So right now, as you can see, we just got two unknowns. We just got two variables. We got a I1 and I2. We don't got I3. And that is very useful because for three resistors, which would have rather created three equations because we got three unknowns, we just got two, which is a positive. It's actually advantageous for us. Now, as I1 minus I2 comes to this point where the second junction is, that is B, there is also going to be a split. So let us say that part of I1 minus I2 goes through I4, or R4 rather. And let's say the current that goes through R4, let's call it I3. Now, if we do that, we're going to know the amount of current that goes through R5. We just need to take I3 and subtract it from this. And we're going to have the rest of the current that goes through R5. So in order to find that current, we're just going to have I1 minus I2 minus I3. So this is going to be the current that goes through R5. Now, as you can see, we got 1, 2, 3, 4, 5 unknowns. But we just got 3 currents. Now, in solving DC circuits, you're going to need to create simultaneous equations. And then you need to solve those equations to find out the unknowns, that is, the currents. Now, we should have had 5 currents created. That should have needed 5 equations, right? But right now, we don't got that. We just got 3. We just got I1, I2, and I3. So you would just need to use 3 equations to arrive at your answer, which is pretty much beneficial and advantageous as far as solving these things is concerned. So I just hope you understand. Now we're moving to the next video where we're going to take up questions under this and apply these principles created from this video. Feel free to check that out in the comment section.